So this video we will see how to design a mat foundation or a raft foundation in Staad Foundation Advanced. Go to this import Staad Pro option, select your Staad file and then click open. So the program will ask for the load cases which you would like to bring into Staad Foundation. So here itself we can change the type of load case here, or even afterwards once you bring it to Staad Foundation you can change it. So I will change it later. So I am importing all the existing load cases to Staad Foundation. So now all the support reactions, support details are imported to Staad Foundation. First step, we will go to loads and factors and change the load cases here. So first 12 cases is primary load cases, then 100 to 160 is ultimate load cases, and then the remaining load cases are service load cases. Then we can change the SPC pile or SPC factors here. For wind and seismic cases we can change the factors here. For this session I'm not changing this value, but you can change it in case it required. Then go to job setup, create a new job. So we'll give a file name for this job. Select the foundation type. This time we will select mat foundation. Select the design code, then default unit type is SI. So we will select these 3 footings as a mat foundation. So assign to selected supports. Now we can select all the load cases and create job. So the mat foundation job is successfully created here. So you can start inputting the design parameters. So there are some default properties. We can go through this and we can change from this window here the default parameters, or later also we can change that. And now we need to create a mat. For that the easier method is we can make a grid, and then on that grid we can start inputting our mat foundation sizes. So the default grid system we can edit it here in the foundation plan. In the linear grid setup, if you go, we can change this grid sizes. So right now the spacing is 0.25 meter, spacing in Z direction is 0.25 meter, and lines left to the origin 4, so almost 1 meter left side. And these 3 footings we are designing as a mat foundation, so I need little more grid spacing here towards this right side. So I will increase the spacing or increase the number of grids towards right side. So from the lines right to the origin it is 15 now. Let me make it 20, and you can click generate here. So you can see the grid spacing adjusted now. So I'll make it 30. Yeah, I think this will work out. And grid lines top of the origin 4, so almost 1 meter I will get from here. Then yeah, maybe this in case I need, you can reduce this also if required. Okay, so at least we got a grid we created a generated the grid so that our mat foundation initial sizes can be accommodated. So here we can draw our mat. So let me give 1 meter projection on all the sides. So maybe this is the this point will be the center line of the column. So 1 2 3 4 uh, 4 towards top and 1 meter towards left. So I may have to start from here. So I can start from this corner itself. So I will select I will go to tool section, and there is an option to add rectangular boundary here. Add rectangular boundary. So I'll just select this node, and I'll go from this column another 1 meter, say 1 2 3 4, and from here, yeah, I have to give a region name for this. So you can see this boundary has been created now here for the mat foundation. So you can switch off the grid and see the mat foundation what we created. So these dimensions you can change later also. So let me save this file. Yeah. So once the mat boundary is created, then we need to uh, create the mesh here. So in this area also you can create different types of shapes here, like rectangular, which you have seen now, even an odd shape of a polygon kind of boundary also you can create. There are different kinds of boundary creations in this area, and later we need to mesh the mat which we created. So in this meshing setup, you have to add the region initially. So if there are two or three, one or two or more number of regions, you select the region and then click on the add, so it will come here. This we need to mesh. So once you click here, then it is the color become red and it is selected. Now once you select the mesh or region, you can generate the mesh here. Okay, so the mesh is created in a different elevation. That is what this error message comes. So what we will do, we will edit the region selected. So go to this edit region of selected tree. Then you can see the y coordinates in this pop up here, because in the Staad the supports were at the -2 coordinate. So here it create the mat which the region which I created came in 0 coordinate. So that is the error showing. So I'll make it -2 for all the coordinates here. And in this area, if you want to change the coordinates, or you want to change the dimensions of the mat, that also we can do it in this window here. So we can edit x and z coordinates in this region, and the mat dimensions can be adjusted accordingly. So now I'll generate the mesh. So it will ask type of mesh, and the what kind of meshing, or different meshing options are there. You can select which meshing option, and then you can click OK. Now the mesh is generated here. So next step, we have to give the analysis properties. Slab thickness. So let's and the default thickness is 0.3. Let's say we are giving 0.4. So it will ask analysis thickness as well as design thickness. Then the soil properties we need to input. So soil density you can give, then subgrade modulus of reaction you can give, here you have an option to calculate the subgrade modulus of reactions also. So if allowable bearing capacity is say 200, and safety factor for calculating allowable bearing capacity is 3, and settlement is whatever the permissible settlement it is there, input that and click on this calculate. So it will give you uh, the modulus of subgrade reaction based on this equation. This value you can input here in case you require. So we can change this to 8000, and the soil height above the mat, that too we can input here. Then next step, it is the analysis. We need to analyze this mat foundation with the loads and load combinations, and then we need to generate the moment envelope and then design it. So we can analyze it initially. So now analysis is completed. Now we can close this, and then you can go to the moment envelope generations. So here you can select your uh, the region or mat. Then you can generate the moment envelope along x and z direction. So initially we'll generate the moment envelope for x direction, and then along y direction, z direction. Again, once the analysis is completed, we can see the results in this calculation area. So wherein we can see all the coordinates we provided, and the load details which we are inputted, and then your foundation and soil subgrade modulus, all those details we'll get it here, and we'll get the node displacement summary, and plate stresses summary will get, and the soil pressure summary will get, and sliding overturning check. All this the analysis result it will be available in this calculation area. And once the moment envelope generated, we can go to slab designer, and then you can give the clear covers, a grade of concrete, steel, and other parameters, and you can just check the design reinforcement required. So here you'll get a summary like this: the longitudinal top and bottom rebars, the transverse top and bottom rebars. So based on the maximum moment envelope which is generated, the area required for AST required uh, will be provided here by the program, and you can see which load case and which plate number you have the maximum loads available. And you can see a detailed report also here in this way, the moment in each plate, and then longitudinal top and bottom, and transverse top and bottom. So detailed report also available, and you can check the punching shear at these 3 column locations, whether it is passing or not. Those details we can verify here. Even you can take printout of these results, and summary of result will be, we have seen that summary result, and then detailed report also available. Yeah, after that you can see a detailed calculation sheet. You can print it, and then you can use it in your calculations. GA drawings will be generated, but not sections and other things, but general GA drawings will be generated. The foundation size, locations, mat size, etc. Will be here. Yeah, in this mat, in case we want to add some beams, some tie beams here, those things we can do it like in this mat foundation job, the after default properties there is an area called physical beam table. So you click on this and go to tool ribbon, and then there is a provision to add beam here. So add beam, select your columns, and we are just adding two beams here. So mesh need to be regenerated, that is what the message we received. So in the right hand side you can see the uh, beam dimensions, so we can change these beam dimensions also in case we required to change it. So so based on this is a new tie beam which you are adding in the mat, and now you need to mesh the mat again and redo the analysis. So the effect of beam will be considered into the analysis and design. Similarly, in case you want to add some extra loads which is not there in the model, that also we can do. We can come to these loads and factors, and you can add some few new members load, new area loads. So those we can explore this area if in case we need to add some new loads also. Thank you.